Find equivalent capacitor of the given diagram. See, capacitance is formed, capacitor is formed between two plates, and main importance is connected to different point, connected to different points. Now here let us see, let us give the name. This is plate number 1, this is plate number 2, this is plate number 3, and this is plate number 4. All are equally spaced. Equally spaced means all are equally spaced plates and same area of plates. It means the capacitance all will have, therefore all will have same capacitance. All will have same capacitance. Now let us, we have termed, you see that 1 is connected with the 4. Let us write 1 is connected with the 4. It means this is 1, plate number 1, it is connected with 4. See, 1 is directly connected, then it is not joined, it is connected with the 4 directly. And see, 1 and 2 are connected to different points. It means it is forming a capacitor. 2 and 3 are connected to different plates, different points. So it is also forming a capacitor. And 3 and 4 are connected to different points. Okay. Now, second thing we can see, to plate 2 connected to, plate 2 is connected to point A, and 3 connected to point B. 3 is connected to point B. It means 2 and 3 are at different points. So 1 is connected, we have seen 1 is connected and 4 are connected through the wire. So 1 and 4 are connected through the wire first. Now 1 and 2 is forming a capacitor. It means we can write this is capacitor 2, 1 and 2 is forming a capacitor, and here is 3 and 4. 3 and 4 is forming a capacitor. It means 3 and 4 is forming. It means 3 and 4 is forming another capacitor. Now 2 and 3 are connected to point, 2 is 3 connected to point A, 3 is connected to point B. So 2 is connected to point A, and 3 is connected to point B. 2 is connected to point, okay. Now one more connection, 2 and 3 forming a capacitor. It means from 2 and from 3. This we can write it like this. All the same if you are writing, because from A 2 is connected, and from B 2 and 3, because 2 is connected to A, 3 is connected to B. This is forming a capacitor. All will have same capacitor because their distance of separation is same and their area of each plate are also same. So this is the condition how it is connected. It means this and this are in series. It means C equivalent 1 is equal to this is equal to 1 by C equal to multiply these two, divide by their addition, is equal to C square by 2C is equal to C by this C by 2. So this is combined, it will form C by 2, and this C by 2. So when it is combined, this will become like this. C by 2, and this is C, and this is point A, and this is point B. This is equivalent circuit for this one, and this is one. These both are in parallel. Therefore, C net, it means combined of this one, both are parallel. It means we have to add C by 2 plus C is equal to 3 by 2 C. Since capacitance, air capacitance, so A into epsilon naught by D, because air is kept. If it is nothing is given, we assume air is kept. C epsilon naught D. So therefore, C net is equal to 3 by 2 into A epsilon naught by D. This is the effective capacitors of this given arrangement. In this problem, find equivalent capacitor. First, name all the plates. 1, 2, 3, 4. We know 1 and 3 are connected to same point, and 2 and 1 and 2 are connected different point. 2 and 3 are connected to different point because 2 is connected to A, 3 is connected to this point, and 3 and 4 are connected to different point. It means 1 and 2 is forming a capacitor, 2 and 3 is forming a capacitor, and 3 and 4 is forming a capacitor. All are having equally spaced plates. It means D is same for all, and all are having equal area of plates. It means capacitor C1 is equal to C2 is equal to C3 is equal to, there are 3 capacitors, there will be 1, 2, 3 capacitor is equal to C, which is equal to A into epsilon naught by D, because all are forming parallel plate capacitor. Now let us analyze which one is forming where. See, 1 and 3 are connected to same point. It means let us see 1 and 3. 1 and 3 are connected to same point. 1 and 2, 3 connected to same point, and 2 and 3 and 4. 1 and 3 and 3 and 4. This is 3. So now we can have one more 3. 3 and 4, and 4 is connected to point B. So 3 and 4. This is because this is 3. 3 and 4 is forming. 4 are forming 1. This is 1 and this is 3. And 2 and 3 are connected. 2 is connected to point A. See, 1 is connected to 2 is connected to point A. So 2 is connected to point A, and 2 is connected to point A. Again, the same 2 and 3 is forming a capacitor. It means from A 2 is connected. This is 3, 2 and 3. Is it correct or see? Let us see. See, 1 and 3 are connected to same point. 1 and 3 through the same point. Okay. 2 and 3. 2 is connected to point A, 2 is connected to point A, and 2 and 3 are forming a capacitor. Then 3 and 4 connected to, 4 is connected to point B, and 3 and 4 forming a capacitor. It means we can easily say this and these are in series, parallel, and this one is with this one. So all are having equivalent capacitor because of the area of difference, the separation of between the plate is same and the area is also same. That is A1 is equal to A2 is equal to A3 is equal to A, and D1 is equal to D2 is equal to D3. So now we can say these two are in series. So this is point A. This since C and C, this will become 2C in parallel with in series with C. So this will be like this. So because this is C, when we add it parallel to C, it will become C plus C, 2C. Okay, now these both are in series. Therefore, C net is equal to, this is 2C multiplied by C and 2C plus C. Therefore, C net is equal to 2C square divided by 3C. 2C square divided by 3C is equal to 2 by 3C or 2 by 3 where C is equal to A epsilon naught by D. This is the C net for this given circuit. Just we see, first of all, in the analysis we have to see both are, if it is forming a capacitor, both are connected to different points, and then you see which point is connected to where and how it is forming the capacitor, and solve it, we will get the answer like this.